Making progress.
Yeah, it's just now.
All right, welcome everyone. So to get us started, a reminder that tomorrow is our review for exam 1. So there is a practice exam up on Canvas, which contains our instructions for the exam. So on the actual exam, you'll have 60 minutes and 1 attempt. You have a 3" by 5" note card. You can put whatever you want on it on both sides. Reminder, it's not an open book exam. You try to treat it like an open book exam. I anticipate that it will take you more than an hour to look up all the things you need to know. So I encourage you to study for this exam and take notes on your 3" by 5" note card so you can quickly refer to whatever you want to find. Are there any questions about the logistics for the exam? All right.
So if we take the full time limit, you'll assume that for cheating?
No. No, that is my warning to you about why you should prepare to take the exam and not pretend it's an open book exam just because it's an online exam. So I would encourage you to please try the practice exam before class tomorrow. If you finish that and want additional practice, there are extra practice problems just in a Word document on Canvas here. So whatever studying you do between now and tomorrow, that will give you extra fodder to know what you want to ask about in class during our review session. All right. Are there any questions about homework 5? Okay.
I know that you did it in class, but can you just go over problem 1?
Problem 1. Okay, so this was, we had the 1 proportion applet graph. And I think we did part A in class. Did you want to do part A?
Could you please?
Yeah, all right.
You do A.
Part A and B, sure. So actually, I think we did this on the board, so let's do this on the Word document so that it's on the recording. All right, so, oops. Our question was, according to the empirical rule, under the chance model, approximately 0.15% of repetitions will have sample proportions p hat greater than or equal to blank. So in this problem, we're being given the percentage of the data, and we're being asked to find the threshold that cuts that off. So if you look at your graph of the empirical rule, where do you see 0.15%? JJ?
3 standard deviations.
Yeah, so 0.15% of data is 3 or more standard deviations above the mean, and same thing for 3 or more standard deviations below the mean. Here, the question is asking us about p hat greater than or equal to. So we want to find some value, like and maybe it'll be like 0.19, somewhere around there. And we want the probability of being greater than or equal to that to be 0.15%. So 0.0015 would be the probability. So that means that we're looking at 3 or more standard deviations above the mean. So we want to be in this category. Oops. There we go. So in other words, we're looking for what value X gives a standardized statistic, or z-score, of 3. So then 3 or more standard deviations above the mean would be that value or higher. So to find that, we can set up our 3 equals X minus the mean divided by the standard deviation. So we don't know what X is, we're trying to find that. But from the applet, we have that the mean is 0.15, and that looks correct, right? Because we did this applet with the probability of heads being 0.15, and we know that the mean of p hat should be pi. So the mean of p hat should be 0.15. So that's our mean, and the standard deviation is 0.018. So that should be the square root of pi times 1 minus pi divided by n. All right. So that means that X is equal to 3 times 0.018 plus 0.15. Let's just use Google as a calculator here. 3 times 0.018 plus 0.15, 0.204. So that's saying that on our null distribution here, so the dot plot, if we go to 0.204, 0.15% of the simulations will be greater than or equal to that. So then, now let's suppose we're testing the hypothesis that pi equals 0.15 versus pi is greater than 0.15. And we want to know approximately what p-value we would expect if our observed sample proportion was p hat equal to 0.204. So the p-value is going to be the probability of getting a result at least as extreme as what we observed in the data. So in other words, what's the probability of being at 0.204 or greater? Or in other words, what proportion of the simulations are going to be at 0.204 or greater? Well, we just said that 0.15% of the simulations are going to be at that value or greater. So all this question is really asking is take this 0.15% and change it from a percent into a proportion. And the way we do that is by dividing it by 100. So that's going to move our decimal point over by 2. So 0.0015. So in this case, the numerical computation that we're doing is pretty easy. We're just dividing by 100. The tricky part is understanding the connection between parts A and B to understand why the answer to part B is just taking this 0.15% and turning it into a proportion. And that's because of the definition of a p-value, is that the p-value is how common is it to get a result at least as extreme as what we got in the data in this null distribution. Questions about that? Other questions about the homework? All right, so for today, we have this investigation that sort of combines the ideas from throughout chapter 1 to investigate this question of whether people are more likely to pick the right front tire when they have to guess which tire went flat, if they're just making it up. So please give this a try with your groups. You'll be able to compare your answers to the pre-class reading as a way to get you started. And let me know if you have questions.
Oh, yeah. I told my friends. I told my friends about it.
And for anybody who's watching this recording later, this is the chapter 1 investigation.
I would know.
Anyway, this is the long portion. Oh, like. Entire.
It's the right up here. I think I'll probably. But I feel
Yeah.
more. I mean, if you have one, just start.
Yeah.
Oh, I don't.
Yeah.
Yeah. My dad said not to.
I love it. What's my
So I don't see it a little bit. I think we did the first part. Oh, yeah. It's the same thing that I read, right? I didn't. If it's, yeah. I would be like trying to. I'm gonna do violent PDF. Discuss with the person who called what we're doing. So.
We're looking at the alternative.
So it has been conjectured that students tend to answer right front more than.
So they have a reason to make it seem one way or the other, it's not just not. So they're like, we don't know, then it'd be.
Sort of see that.
Yeah. Right. Obviously, no. I'm on the next right. So what's the? Which one's the? Probably front, because this one's gonna be turn, right? The other one's just drink behind it. So.
Oh, depends like
If you're four-wheel drive too.
Yeah. Okay.
it's just.
Okay, I don't wanna do it.
So it's. So like it's like the. I was going off.
Yeah.
Where is?
Yeah, we can make a difference.
14 and 28.
It would work.
Yeah.
It wouldn't be amazing.
Will it work?
No, this is-
Are there at least 10 successes?
Okay, so this is that n times 5 and yeah. So it is
Your brain.
20 to 5 times.
Or if it's the number. But if it's enough. Yeah. Isn't it just?
That was my mistake. No. No. I'm pretty sure.
Oh, we're not using one. No, I was thinking of.
But is M equals to, is M 28 or 14?
A little bit.
Is that the full sample or the? I think it's, I'm gonna say 28.
Yeah, so they're.
Yeah.
But everybody's like, let's.
Correct. I just did that.
Okay.
Okay, and the standard deviation.
I feel like it is.
Yeah, and then this one, it's the, you don't divide. Just no. 0.245 and then 0.75. Yeah, but it's the multiplying one, not the dividing. Yeah, so it's 0.295.
That is very good, but that is for a number of people who said right front, not the portion of people who said right front.
For the deviation.
Or both.
This value is the other.
One is the other.
So it is.
You don't have to erase that. Just like, that's the number of successes.
Yeah.
That's the number.
Also, and here's the number.
Okay, I don't know if they do the game, but I know. Well, no.
They're both right.
I did,
Both of those would be if this were, like, all this would be the number of successes.
Oh,
So it would be just. I know. Yeah, it does. No, that's, you said that's for the. It's not for successes.
The number of, if this were of the null distribution of the number of successes, then it'd be 28 times.
But since this is from.
Yes.
Wait,
I thought we had to say.
Good question. That's actually the approximation for the landscape. Even if the distribution isn't going to be
Right?
oh, so if it did want us to have a number, what would it say?
It's
Instead of like, I'll say so.
The number of successes.
number of successes or number of students who chose right front, or maybe just X. But I call it, I call it an X.
So be like asking for something specific on our mistakes.
Yeah, if it's P hat, then it's the proportion.
So it's undistributed is 5, 1 times 1 minus 5 divided by. So it's.
Make sure put all of it under the square root too.
Yeah, all of it.
Which was I
An answer. That was around 0.0. Just an answer. Unfortunately, uh-oh, we need an iPad.
So.
0.01. Sorry. Where does B instead of B?
I think.
We do the next slide. Alright.
So you, I'll wait for you.
Thank you. Yes, we could do that.
Okay, well, we're.
Alright.
It's the mean is 9.
Wait. Oh, I did. Wait.
And 2 or something.
So.
Yeah, all this question.
Let's go.
It's basically the one.
Okay, so our predictions are spot
Pretty sure there's slight.
on. Well, if you, I'm putting spot on.
Close. Very.
Okay, and then, I'll put spot on ish. I have an ish in there. Pretty good.
It's like, oh, it's
Okay, now we. Fine. So it's 0.25. Don't want to stop me if I just, if that was incorrect.
Oh, sorry. That's why I got
okay.
Wow. That's the same.
Oh, okay.
It's interrupted me.
I know. It's gotta be the same. It is?
Yeah.
Yep. Told you. Yeah, tell me your turn.
Okay, because if you go, it'll just. Okay, so this one is CDF.
This.
I'm not, that was a question. It was a
Was
question.
it rhetorical?
No, it's since you don't.
So that right? How would you log in?
Oh, I think it might be 1 minus.
Thanks, man.
It's one minus because it's the key answer. Wait, so it's 14 or 13? So it's 14.
I think it's 14 as well. So I'm not sure.
I'm pretty sure it's 14.
I think it's not.
Yeah.
I didn't touch my calculator.
What do you get?
Okay, like, pull back up. 00378.
Okay, well, if you don't, you can really answer so. I never know.
I think.
I'm gonna ask.
Draw the number line and then you'll see.
Okay, okay, 13, not 14. Why?
Because we need one minus.
You wanna know all the ones.
Whatever's not
above?
colored, you want the number line, you want to get rid of.
So yeah.
So you want to include 14 there for you, for later.
Yeah. Whatever you want.
Subtracting.
Yeah, it's actually good. Whatever you want to use.
Don't use it. What?
If that's not thinking about it, for you, that was all right.
I guess that works. Okay, because sometimes when we can use 14, so like the one. So in the homework or in the extra problems that I did.
So if the alternative hypothesis was that pi is less than whatever, then to find the p-value, we want to find the probability of 14 or fewer. So the probability that x is less than or equal to 14.
And then you want.
So then you just use binomial CDF of 14 and you wouldn't do the 1 minus.
If I use 0, 1 minus, binomial CDF is always going to be 1 less than.
If you're using it to find a p-value.
Okay.
Sometimes the homework problems where it's not a p-value, it's just a probability, so it'll be tricky and it'll be like the probability that less than.
Yeah, because I printed out the extra homework. Because I was confused, like, with these. It's like sometimes they, like this one uses 6 times 7, but like this one here uses 10.
Right, because this one is you're finding the probability of x is less than or equal to 10. So equal.
I just said right.
Yeah, because you want to include 10 in your range of probabilities.
So then why if this is n equals it's still 10?
Because there, you want to find the probability of 13 or more, like 13 to 14.
Oh, right, so it's the other, yeah, right. Okay. I think I got it.
There's Ross number less than 20.
What? I think one cup.
I haven't decided,
I know.
but I just pictured it in my head and I came up with that, so. Maybe I should start. Yeah,
It's sports.
that makes sense in my head as well.
Okay. Sports alternative.
Okay. Figure it out more.
Yeah.
Okay, we'll go to that.
Yes.
Okay, so.
Yeah.
Okay, what we're saying is that each has more or less than others. So. Yeah, each has more accurate, or not more accurate. Sorry, I'm against the hypothesis, but it's less accurate. So when we say we don't trust that as much.
Yeah, I would say I don't trust that one quite as much because our number of successes and failures was not that much higher than that.
Which one is the most accurate?
The binomial probability, assuming you calculate it correctly, that gives you the exact answer.
Okay, this one's based on the actual.
We just found this.
So this one is typically better than the one that it has, especially in a small size. But because it involves randomness, you're not going to get the same values.
Yeah.
So in that respect.
Now, if we did the one prop test that had larger sample, like pretty large sample, but this is still.
The binomial distribution is still the gold standard,
Okay.
but in a larger sample size, you would expect these two values to be closer.
Okay, all right.
I think it's.
I don't trust the one from t-text.
You don't like that one?
Yeah, even though it supports our, no.
Do they all support?
Yeah, very strong.
It's not really that accurate though.
Do they all support it?
Yeah.
Since it's a small.
I said they all lead to the same strength. They're all strong evidence. One from t-test is like, it's accurate of three.
And strong evidence against.
Strong evidence of Brian Sharon.
Oh, that's just.
Or the normal.
That's gonna be.
As long as they're so key had.
So.
Apparently, I don't know that. Let's keep that.
So we're asking like.
I'll try to solve.
I don't know how to.
Yeah, might not be the solid.
It might-
What is up, those class, you have to. Do them.
Well, I think it was all kind of like.
Subtract your large, take these two. See, that's maybe.
It's hard to one.
That you
Yeah,
said,
we don't know, we just walk around, we guys.
Yep.
What?
The answer key to that is.
Yeah.
Last one more.
I was going
And then we just find a real one, like, specific to artists.
I don't know what. I can also.
And you're working like
Really?
I started yesterday.
I started yesterday.
I know all. But
I only know 3, that's the only one I studied was 3 and 4.
I started for, I'm also like not watch that lecture. So I don't really know more.
I only started 6.
Yeah, that's for next test though.
But it wasn't sanitizing stuff. Well, no, that's part of that.
Yeah.
Yeah,
So
Chapter
we're getting
5.
this in, so there.
I don't watch it.
That's just my faculty.
Oh. Sanitizing stuff.
I feel like she's gonna ask like.
I know, like which one would be better for?
Like the smallest detail that was on PowerPoint.
That's what
About this.
Huh?
About that.
We're talking about the lecture exam.
Yeah, I guess.
I still love that.
I think I'll be fine with the last exam when it comes up, but it's just lectures, I guess. I don't know, there's just a
I
lot.
like the lecture one the most.
I haven't started.
I have not. I've only been studying a lot because of the quizzes during class.
I'm better at the lecture ones because I don't like doing stuff. She's annoying, she's so listen words. I don't understand.
But then,
No, I
just
actually
our
like
memorization.
I did.
Just
I got the, one thousand slide on the lectures. It's only like 175 more to go.
But like when you.
I haven't even finished watching videos.
Yeah, I'm not.
That doesn't before though. Level.
Yeah, the lab is until like 3 hours. Also fun for us. Oh, but the lecture is like. This is fun. Our lab one is. Private.
Yeah. So I don't have a lecture ever since.
No, either weekend, either weekend.
Huh?
Yeah, I just think you.
Yeah, we can just study.
Yeah.
Okay.
That's how it was.
So it is, yeah.
I mean, it's only 4 points.
And it's in like a 5% category.
Yeah, so it's
I know
not.
it's chill. I don't know.
What's the last time? Where
Oh, man.
All right, so let's talk about some of the highlights of this activity. So is a normal distribution likely to be a good approximation for the null distribution of p hat? Let's say thumbs up for yes, thumbs down for no. Yeah, I'd say thumbs up seems good. Caitlin, do you want to say why your group said yes?
Yeah, there's more than 10 successes and more than 10 failures.
Sounds good. Yeah, there are more than 10 successes and more than 10 failures. And then let's predict the mean and standard deviation of the null distribution of p hat. So let's start with the mean. Table 3. What formula should I use to predict the mean? Which mean? Nice.
I think it would just be the proportion,
Yeah, which proportion?
like, one about
Yeah, the value from the null hypothesis, which was 1 out of 4, because we're saying, do they answer right front more than would be expected by chance? So out of 4 options. So the mean is just pi, the value from the null hypothesis. So 0.25. What about the standard deviation? Table 2, what formula should I use for this?
the square root of fraction pi times 1 minus pi over sample size.
Yeah, so all of that is under the square root. And what did that end up being equal to?
Zero point 08183. 0.082.
Like that?
Yeah.
All right, good. So these are the formulas we want because the question asked about the null distribution of p hat. So p hat is the sample proportion of successes. If it had asked about the null distribution of the number of people who said right front, then we would be using the other formulas. We'd be using n times pi for the mean, and we'd be multiplying by n rather than dividing by n for the standard deviation. So it's important to look at which one the question is asking about. Are there questions about that part of this? Caitlin. Yeah, so if the question had been, predict the mean and standard deviation of the null distribution of the number of successes, or the number of people who said right front. In that case, the thing you're finding the mean of is the like whole number of people who said something. So it's gonna have a larger mean than the proportion of people who said something, because you know that has to be between 0 and 1. All right, hopefully the mean and standard deviation in the applet were close to what you found using the formulas. Excellent. All right, I want to skip down to using the binomial distribution to compute a theory-based p-value. So we need to figure out what number to put into our binom CDF. And the way I recommend doing this is to draw a number line. Usually when I'm doing these problems, I think about the number line in my head, but no shame if you spend the entire semester writing down the number line. That's better than getting the question wrong because you were trying to do it in your head and got it mixed up. So 0, 1, 2, ... 13, 14, 15, ... up to 28 are the possible numbers of people who could say right front. And we want to find the probability that 14 or something more extreme said right front. And based on our alternative hypothesis was that pi was greater than 0.25. So what counts as more extreme than 14 is stuff that's greater than 14. So 14 through 28, that's our event E that we want to find the probability of. So the probability of E, or the probability that the number of successes is greater than or equal to 14, is going to be 1 minus the probability of E complement, or 1 minus the probability that X is less than or equal to what number? It's your table 5, you haven't information yet. 13. Because that's the first thing here that we didn't highlight. So that's the first thing in the complement. So that means this is going to be one minus binom CDF of 28, 0.25, 13. Caitlin. When you're finding a p-value, you always want to find the probability of what we got in the data or something more extreme. So when you're finding a p-value, you want to include the 14, that's what we had in our data, in the region that you're finding the probability of. So in our highlighted event E. And in this case, because binom CDF will only tell us the probability of being less than or equal to something, that means we have to use the complement rule with 13 or less. In a problem that doesn't involve the p-value, then you would look at, are we trying to find the probability of 14 or more, or are we just trying to find the probability of more than 14? So you have to look at the way the problem is worded.
So if it was more than 14, you would put 14 in there?
Right. If this were a non-p-value question that asked, just find the p-value that more than 14 people chose right front, then it would be 1 minus binom CDF of 14 to get rid of the probability of 14 and only be computing the probability of 15 or more. All right, and then for our last question, do all three p-values lead you to the same conclusion? And if not, is there one that you trust more or less than the others? What do people think about this? First of all, did they all give you the same conclusion? So very strong evidence that people are more likely to say right front than they would be by chance. Good, so we're getting roughly the same amount of evidence from all three of these p-values. So given that, is there one of these p-values that you trust more than the others? Nettie, what did you say? Yeah, I would tend to agree with that because binomial CDF is giving us an exact probability using the binomial distribution. So that's nice as compared to the applet, where the applet, like your p-value is going to fluctuate slightly depending on what random numbers you get. And in particular, the normal approximation, the one proportion z-test, is just an approximation. So it is going to be a little less reliable than the one proportion, than the binomial CDF. And that's particularly true in a case like this, where our number of successes and failures is more than 10, but not hugely more than 10. That's the situation where we can reasonably rely on getting the same conclusion from the one proportion z-test, but the p-value that we get from the one proportion z-test is not going to be as close to the binomial CDF or the applet as it would be if we had a sample size of 10,000 students. Questions about this? All right, great work today. I will see you all tomorrow for our review session. Question about the review session?
I just put my phone out and now it's just. You're welcome. My friend texted me and was like, hey, can we talk? But not like, not all the time.